All right, let's look at subnetting an IPv4 network. So we'll first start out with subnetting it on a octet boundary. So we got 4 octets. Let's look at that because that makes it the easiest way to start grasping what's going on. So the one table you want to look at is, look at this before. You got class A, B, and C there. How did you know A, B, and C? Well, I did it because I knew the subnet mask. What was a class A? It was 255.0.0.0. And it had a prefix notion of 8. Now that prefix length, just keep in mind, it's the number of ones in the subnet mask. So I've got that many networks. So I've got fewer networks, but I have larger number of hosts. So for a large company, you're going to want to use a larger prefix. Same thing with /16, 255.255, N24, 255.255.255. So understanding that at the octet boundary, it makes things a little bit easier. So if I wanted to take a network and say, gee, I've got a class A, so if it's a private network, it starts with what? It starts with 10. So if I wanted to do it on the boundary level, what would I do? I would take the whole octet boundary. So I would take the second octet. So what would I do? I would convert all of the zeros in that second octet into ones. So I would convert a /8 network to a /16 network. So I would increase the number of networks, I would reduce the number of hosts per network, but it would allow me to create more networks with which to use. So when you think about the boundaries, I'm just taking whatever class it is, I'm taking the next full octet. So I'm just taking all 256 subnets. In this case, you can see the ranges, when I subnet the 10.0.0.0/8 network into a /16, so what have I done? I've now created a smaller subset. I've subnetted, I've made a smaller group of networks that fit in here. So you can kind of see here, you started out with 10.0.0.0/16. So that first host range starts with, I start counting on the right. So you got 10.0, because that was my network address, right? I did 16 network bits, so 10 and 0 are all networks. All my host bits starts from 0.1 to 255 to 254. So you said, well, gee, how did that usable host range? Because it's 1 plus the network address. So my network address of this is 10.0.0.0. First usable is add 1. My last usable is the broadcast address, and that broadcast address is what? I look at how big a network can I have. So it basically says I'm going to take 65,000 hosts, go to that next octet, and then go down. So here you've got a broadcast you can't use, you got the network address you can't use, so everything in between comes into play. And all I did was took the whole octet. I went from a /8 to a /16, increased the number of networks, reduced the number of hosts. That same thing applies if I did it on a /24. So what would that do? I would take the first 3 octets. That would all still be network, and I'm only using the last octet for hosts, which means I've got host network of 0, broadcast address of 255, because we said what? The host portion is all ones, is a broadcast address. So you got to look at what the network address is, what the host portion is. The zeros hosts range is the network address. The ones is the broadcast address. And everything in between is usable. So in this case, you've got 10.0.0 is all network. So the first usable address is the network address plus 1. So the address is 10.0.0.1. And the last usable address is what's the broadcast address for this network. So if I looked at what the network address is and then add, and since it's slash 24, I've got to add 255 to it. That's my broadcast. My last usable is subtract 1, gives you the range of 254. Right? So now I've created a whole lot more networks, but they're also a whole lot smaller. Now, the question is, what happens if I don't want to do on the boundaries? Now, the boundaries make it easy because you're just taking I'm moving 8 host bits to network bits, but you don't have to do it on the network boundaries. I can do it on just keep borrowing host bits one at a time, and each one of those borrows a certain number of hosts, reduces the number of hosts by a certain percentage. And what is that based on? It's based on the what? The positional value of that octet. Remember that first bit on the left-hand side was worth 128. Remember that? So it went 128, 64, so on and so forth. So once I borrow one bit in a slash 24 network, make it a slash 24 to a slash 25, I used one bit. I converted one host bit into a network. And as you can see this borrowed one here. Created 2 networks. You say, well, how do I get 2 networks? Well, taking one position, it can either be on or off. 2 possible combinations. One of the networks will start with a 0. One will start with, what's the size? Well, the size is the number of hosts, right? So my next network would start at 128 because I got position 0 and position 1. And because it's in that 128th position, the network starts at 0, and the second network starts at network address of 128. The number of hosts, remember, I can't use the zeros and I can't use the ones. So on every single network, you're automatically reduce the number of usable hosts by 2. And this table kind of goes through, if I borrow 1 bit, my network, you're going to hear something called a magic number. You're going to hear something that says, hey, what is my magic? If I got 1 bit, I got 128 combinations, subtract 2, because I can't use the 0 and I can't use the 1s, gives you 128, 26 usable hosts. When I borrow 2 bits, 2 host bits, 2 bits gives me what? 2 to the second is 4, so it gives me 4 subnets, and each one of those networks has 64 combinations, right? But I can't use the all zeros and I can't use the all ones. So it gives me, I can use 62 total hosts in that subnet. So for each bit you're borrowing, you're reducing the number of hosts, or the number of hosts per network. So I'm increasing the number of networks, reducing the number of hosts, and then the number of usable ones is just always reduced from the total number that is usable in a subnet to usable hosts is always subtracted by 2. Gives you a little different view of that. I would watch this video on the process of subnetting. Now, there's also a video called Magic Number. And you looked at that subnet masks and subnetting. It's like, gee, remember the table I had you draw up that had 128, 64, 32, 16, 8, 4, 2, 1? Remember that table? If you're saying, gee, I want to have a network of 64. How many bits do you think need to be borrowed to get you that 64? And what size is that network? So basically what you're doing is saying, I look at that table, I go, in one of these videos, there's a video I posted on Cheat Sheet. I highly recommend you watching that cheat sheet because this makes his magic number formula so easy. And it's basically just that 128, 64, 32 table I had you draw out is based on the number of bits you're borrowing to say, gee, I'm looking for a network to handle 60, maybe 50 hosts. And basically you're going across that table and says, well, can I get it in 128 the edge? Yeah, but I still got a bunch left over. 64, then look at the next one, 64. 64, next one 32, so 32 is too small. 64, so it's somewhere in that, between 32 and 64, take the 64. 64 ends up being your magic number. So all of your block of addresses will always start starting at 0, we'll start on that magic number, that block size number, all the way through. So I would pay attention to that. Now, I did assign you this packet tracer lab to help you practice subnetting. Now, keep in mind, in the test and all the homework assignments, you can use subnet calculators, and you'll find in most of those IP to decimal or binary to decimal calculations. Most of those calculators will allow you to do subnetting. So don't rule that out of your formula. Let's see, this next session. Create subnets with a /16 prefix. Some subnetting is easier than others. That is true. If you want a subnet that have the same number of hosts and subnets, /16 is kind of like the way to go. But as you can see, it's the same thing. What am I doing? I started with /16 and I'm just borrowing host bits and creating networks and reducing the number of hosts per network. Of course, I've got more combinations to go through, but no need to memorize this table. Just make sure you understand that as you're borrowing a bit, look at its positional value. Now, Cisco loves playing a little bit with this only because you're starting to play with that third octet. And sometimes we don't think of that third octet as being important. And here, if you're looking at large networks, you can do it with the /16. But it's still the same thing. I'm borrowing host bits to create more networks and reducing the number of hosts. I'm not even going to go through this, only because the process is identical. /8, all I'm doing is, again, based on where I'm starting with a /8 network, and then I'm borrowing additional bits, and each one of those bits has a positional value. Now, when you're doing this, just make sure you're starting from the left-hand side of what you borrowed, because I said that subnet mask can't have interspersed ones and zeros. And that's another example. So I'll let you go through all these different examples. Video on going across octets, the same formula applies. So just keep an eye on that. Come on. You can watch the video. Across that HOTAC. And then in this case, looking at different calculating subnet mask. So you're given a subnet mask in decimal format, Of course, they want you to enter the binary representation of that subnet mask. So in this case, what are you doing? So what do I got here? I've got 255 means 1, 2, 3, 4, 5, 6, 7, 8, right? Here I got 1, 2, 3, 4, 5, 6, 7, 8. Gives me 255, 255. Now, when I look at this, 128, my subnet mask is 128, bit positional starting from the left. I get a 1, and then what does that tell me? I've got 7 zeros. Make sure I can count that right. And in this case, what do I get? I get 8 zeros. What would that prefix be? That prefix says, the prefix notation says how many ones, how many network bits are in that subnet mask. In this case, you've got 8 in the 255 and 8 in the second 255 and 1. So I've got 8 and 8 is 16 plus 1 is /17. So let's check if I got it right. And of course you can't see it, but yes, I do have it right. Yeah, I can scroll the screen up. Let me see if I can move that up so you can see it. That is correct. So it is just a way of letting you practice with doing this. Just keep in mind, a subnet mask, a 1 is network, 0s are host. The slash notation is how many network bits are set to 1. So good example to go through. And I would continue to do that. Practice that until you get comfortable with it. And then I gave you the lab 1166 to just practice some calculating subnets. So actually, I'm not sure I gave you that because it's not a subnet. I think that one, just go ahead and practice subnetting to go through. So I'm going to stop my lecture here, and then we'll go on to how do I design a network meeting certain network classifications.